Okay, so here is the problem we are trying to solve today. It's a pretty basic one, but I think it's helpful to talk through concepts of free body diagrams. So here you would see that a body of mass m, which is this, is suspended by two strings, making angles alpha and beta with the horizontal. So we need to find the tensions in the strings, which is T1 and T2. Now, here you would see that there's some part of solutions which are given just to talk through the forces, but let's talk about it in more details. So once you see the body, usually what I would do here is talk about, think about all the forces that are acting in all the directions. Usually it's best to think about forces in horizontal and vertical directions. So for example, if this is the body of mass m here, you could see that the downward force on this will be due to gravity, which will be the weight of it, which will be mg. But there is a force component of the string which is keeping the body from falling down. So there has to be some vertical component of the force from this string and some vertical component of the force from this string, which are both adding up and not letting the body go down. So if you think about this triangle, it's easy to say what the vertical component of the force will be. If you think about sine alpha in this triangle, so this is the vertical force vector-wise we are trying to think. Say this is x. So sine alpha would be x by t1, or the vertical force here would be just simply x equal to t1 sine alpha. In similar fashion, for this string, the vertical component of the force would be t2 sine beta. So all these forces add up on the body. Let's put it here, t1 sine alpha, and then here t2 sine beta. Similarly, if we try to balance the forces in the horizontal direction, because the body is again not moving either to the left or the right, and it's also not moving to the bottom or top, right? So if we now focus on the horizontal direction and try to think of forces, we see that the weight here will not act on the horizontal direction because it's a perpendicular force and any horizontal component will be zero because of this 90-degree angle. And if you want to verify, we can get to it quickly in a moment. The way we did for sine alpha, we can also do for, to identify the horizontal component of the forces here. Let's say in this triangle, this was y. So in this triangle, the horizontal component was y. So it's easy to say again by basic trigonometry that cos alpha would be y by t1, or in other words, y is t1 cos alpha. In similar way, you would say that the horizontal force here would be t2 cos beta. So once we identify these horizontal components, we know that there is no motion on either left or right side. So the forces must balance in that direction. So we would say here that T1 cos alpha and to the left is T2 cos beta must match. So again, applying Newton's laws of motion, we know that if there is no acceleration either side, the body is stationary, then for any given direction, the forces must balance out, which means for horizontal direction, we can say that T1 cos alpha equal to T2 cos beta, which means the horizontal forces are balanced out. Similarly, in vertical direction, we would say that the sum of forces on the upward side, which is T1 sine alpha plus T2 sine beta, that must again equal the sum of forces on the downward side, which is only its weight, or mg. Now, if we were to solve these two equations, two equations with two variables, T1 and T2, other things are known, which means we should be able to solve this. We can simply say that T2 from this equation is T1 cos alpha by cos beta, and we can put this value of T2 over here and write this equation as T1 sine alpha plus T2, which is T1 cos alpha by cos beta multiplied by sine beta equal to mg. And now we can calculate the value of T1, which is simply mg divided by sine alpha plus sine beta cos alpha divided by cos beta. Now you could simplify this more and take the cos beta upside and then expand it as sine alpha cos beta plus sine beta cos alpha, which can further be simplified into sine alpha plus beta if you use more formulas. But that's not the idea. You get the point on how to solve these kind of equations where we can get the value of T1 and then plug it back into this equation and get the value of T2. The essential thing I would want you to focus on here is that first of all, think about all the forces in horizontal directions. See if the body is stationary. You have to make those forces cancel out. And then again, figure out the forces in vertical direction, such as those coming from the strings. Calculate what the vertical component would be, and then those has to match against the weight. And then again, if you solve these two equations, you can get this simply. Now, we can talk about more such examples in subsequent videos where the entire system is moving down. You can let me know on if that would be of interest to you, or we can focus on something else that you would like to see more of. Until then, signing off, and I'll be back in the next one with another problem to solve. Have a good one, guys.